Welcome to the AKG CBL and Blue 50 configuration video. In this video, we will review the steps to configure the AKG CBL 301 microphone for external mute control and how it connects to the BSS SoundWeb London Blue 50 digital signal processor. Using Audio Architect, we will then review how the Blue 50 can be configured to react to a touch event at the microphone and in turn manipulate the LED colors. The CBL 301 and 201 have 4 modes of operation. The mute, push-to-talk, and push-to-mute modes all make use of an internal mute circuit. When operating the CBL 301 in external mute control mode, the microphone's internal mute circuit is bypassed, and the microphone is continuously active. Control signals can then be sent to the digital signal processor to enable or disable mutes found within the DSP's configuration. There are just a few required items to prepare the CBL microphone for being connected to the DSP. In addition to the microphone and digital signal processor, verify that you have the following: a cable stripper tool, a T10 screwdriver to remove the microphone grill to change the microphone's mute mode, a small flathead screwdriver to help loosen the braided shield and tighten the screws found in the Phoenix connectors, also known as Euroblocks or captive screw connectors, and a compatible Phoenix connector block provided with the digital signal processor. To use the microphone in external mute control mode, use a T10 screwdriver to remove the 3 screws found under the base of the microphone that secure the microphone grill. Lift off the grill and set both dip switches to the on position. Replace the microphone grill and move on to preparing the cable. Start by removing a portion of the outer jacket. We recommend approximately 6 inches in order to accommodate audio and control connections that are not located in close proximity. The CBL 301 provides a total of 11 conductors for making audio and control connections. Once the cable has been properly prepared, then individual conductors must be terminated at the Phoenix connectors. The cable's audio ground can be connected to any of the shield connections of the analog inputs being used for the microphone. All shield connections on the Blue 50's analog inputs are internally connected and therefore are not required to jump the ground of all 3 channels of the CBL 301. Using one of the 3-way Phoenix connectors provided with the Blue 50, secure the audio ground and channel 1 hot and cold conductors. These are the red and orange wires respectively. With the Phoenix connector screw heads facing upwards, the connections from left to right are shield, ground, hot, and cold. The brown and black pair of conductors are used for the mute control signals. When operating the microphone in external mute control mode, the brown wire is used for the mute I/O and can be connected to any of the 12 general-purpose inputs, and the black wire is used for the microphone's digital ground and is connected to one of the 2 common connections. When the microphone's touch ring is touched, the mute I/O signal will short to the digital ground and be connected to the DSP. This will require both 12-way Phoenix connector blocks provided with the Blue 50. Finally, the white and gray pair of conductors are used to communicate LED ring colors to the microphone. Depending on their values, the microphone's LED ring can either be off, red, green, or blue. These wires will be connected to the logic outputs 1 and 2 along the bottom row of control ports. We'll see how the mute and LED states can be configured in just a few moments. After verifying all the wires are secured within their respective Phoenix connectors, push all the connectors into place at the digital signal processor. Now we are ready to configure the DSP to operate with the microphone. If you haven't already, make the proper network connections and power on the unit. For this demonstration, we are going to just focus on configuring the Blue 50's mutes to react to a touch event at the microphone, and in turn control the microphone's LED ring. We will not worry about any other processors or routing. Within Audio Architect, we'll add a Blue 50 to our design. We'll just use the one that was automatically discovered on our network. Next, double-click on it and select the analog input card. Let's rename the input channels. For channels 1 through 3, we'll name this CBL tilde. The tilde will maintain the channel number in the signal name. Click OK. Now with the CBL 301 configured for external mute control, any mute found within the Blue 50's audio design can be enabled or disabled. We're just going to focus on the mutes found on channels 1 through 3 of the analog input card. Double-click the input card to expose its control panel. When a touch event takes place at the microphone, we will want all 3 channels to be muted. So let's create a new exact parameter link. Rename it to mic mute, and drag and drop it onto the appropriate mute buttons. Press any one of the 3 mic mutes and we should find that they all turn on and off at the same time. Now, since we want the mic mutes to react to a touch event at the mic, let's move to the Configure Control Ports mode in the Blue 50. With the analog input card's control panel still open, we can control drag any one of the 3 mutes to control port input 1. By default, the mode will be set to direct action, meaning as long as the touch ring is being touched, then the mutes will be activated. The moment it is released, the mutes will deactivate. This can be thought of push to mute. Setting the mode to direct action inverted will result in the opposite behavior. Touching the ring will cause the mutes to be deactivated, and after releasing the ring, the mutes will revert to being activated. We can think of this as push to talk. Toggle action will cause the mute to alternate states based on the momentarily shorting of the mute I/O signal to the digital ground, and does not require the user to continuously touch the ring to activate or deactivate the mutes. This operation is similar to the default mute mode. We'll just leave it set here. Multi-state mode is not applicable for this application. Finally, the microphone's LED ring color is determined by external control when using the microphone in external mute control mode. You'll recall we connected 2 wires, logic outputs 1 and 2. Depending on how we send high or low voltage control signal across these 2 wires, we can determine the color of the ring. In this demonstration, we want the LED ring to be off as long as the mutes are deactivated, and the LED ring should be red if the mutes are activated. To accomplish this, we can simply control drag any one of the mutes to control port 1 and leave its mode set to normal. When the mute is activated, only a high 5-volt voltage control signal will be sent across the white LED wire to the microphone. When deactivated, the LED ring will revert to an off state. This concludes our demonstration. For more info, please visit akg.com, and thanks for watching.